Hi there, guys and gals. We've got a great lesson today, extending that idea of binomial distributions that we learned today or yesterday, where you might have noticed in the homework they're asking, are you surprised at your results? And we're not going to deal too much with your feelings in this section too much, but we're going to talk about mathematical feelings to see when we're mathematically surprised or something statistically significant is happening. So the format we want you to write this is in 5 steps, and you don't have to write them as 1, 2, 3, 4, 5, but you just have to make sure you have all of this information. So I'm going to give you some notes that I would expect you have tomorrow written down, but you don't have to write this verbatim. So let's just walk through those steps. When you run through a binomial situation, you always have a p-value. So in step 1, we want you to state that p-value, but we kind of want to be skeptical of it, that maybe the p-value is from a survey and we wonder when it was taken. There's also p-values that are true facts, like flipping a coin, rolling a dice, spinning a spinner. We know those probabilities are always going to be true no matter what the situation is. And that's going to come into play very down here at step 5. So the first thing we're going to do, I would put maybe in your notes, is state p. So state the probability you're dealing with. In number 2, you got to find some information about the situation. So in that case, with your certain sample size, you're going to verify if this is normal. And we talked about this today. We took some notes to say that to check if it's normal, our successes have to be greater than 10, and our failures have to be greater than or equal to 10. Once we know it's a normal distribution, we can get a lot of information from that. So it says we're going to compute its mean and standard deviation in step 2. So again, the mean is n times p. The standard deviation is the square root of n times p times 1 minus p. So you find a lot of the core material or core ideas in number 2. We move on to number 3 that says take a random sample. Well, I'm not going to send you out there and take some samples on certain things. So you're going to get that from the problem and just state what it is. So get that from the problem. We might say, recently we went out and surveyed 100 people and 70 people said that. So from our specific thing, we got 70 people. Number 4 is a very important one. This is where we start to make some of our conclusions or information for our conclusions. Step 4, we're going to determine how many standard deviations the number of successes in your sample is from the mean. That's a big way of saying z-score. So whatever you put in 3, you're going to find the z-score of to see how rare it is. How far away from the mean is it? Is this something that should have happened? Is it close to the mean, or is it far away from the mean? That's what a z-score tells us. What a lot of people forget about in 4 is you need to include a sketch. It's always nice to have a frame of reference to see where these values lie. So put your mean, go 3 standard deviations up, 3 standard deviations less. So if I know what my population or what my actual sample value is, I can just look there and say, oh yeah, it's close to the mean, not very rare. But if it's way outside, then I might be able to make a conclusion. Step 5 is where we get into the nitty-gritty here. If the number of successes in your sample is more than 2 standard deviations away, it's declared statistically significant. So that's the big new thing today. If your z is greater than or equal to 2, or the z is less than or equal to 2, we say it's statistically significant. Something significant, I'm talking right, significant. Something weird has happened. We're really far away from the mean. So when something weird's happened, there's 2 things that can happen. These 2 bullet points are where students have a lot of struggles. What we mean by you have the right p-value for your population, but a rare event occurred. For a rare event, the p is something that we know is a fact. You might be asking, well, what probability is a fact? Maybe flipping a coin. So if I flip a coin 100 times and I get 90 heads, I know that probability is 50% and I'm getting something really, really far away from it. You know, rolling a die, spinning a spinner. Those are all probabilities that we know, are facts. If it's not something that you know for sure, some mathematical probability that we've been talking about, our second conclusion, or our other conclusion, I should say, is that your p-value is wrong. Now this comes into play maybe when you look at a sample or a survey. Maybe they polled some people to say, 30% are women in this population. And then we find from our sample, it's not 30%, it's way higher, and it's statistically significant. Maybe that p-value is wrong. Maybe it's an old population or old p-value. So what we're trying to do here is find events that are weird. They are rare, maybe not rare events, but they shouldn't be happening with the numbers that we have. And then you just have to determine if your p-value is something that you know is always going to be true, the 50%, the 1/6 of dice, or maybe they just have a sample that where they went out and said, hey, 15% of people like dogs. So that might change over time. People change over time. So those are the notes I would expect you to have by tomorrow. I'm going to go through one example if you want to keep watching. It's a really cool survey that I put out. A recent study was taken at WHS, and it was found that 95% of the student body thought Mr. P was awesome. So, I mean, this is obviously true, but who knows who Mr. P is. But if you take a sample, you go out of 830 students, say senior class, would you be surprised that 810 people said they did? Now, the biggest mistake people do is they divide 810 by 830 and say, that's 90-some%. No, I'm not surprised. We have to be mathematically surprised. We have to go through the 5 steps. So as you can see, the first step, I state my p-value, 0.95. 2, I want to check if it's normal. This 830 times 0.95, I think is 788.5. So that is greater than or equal to 10. My failures from 830 then is 41.5. So both are greater than 10. Show those numbers that they are greater than 10. Then I can find my mean and standard deviation. As you can see, n times p, standard deviation, and do round this number to 2 decimals just to stay consistent. Don't try and make it into a fraction or anything. Just round that to 2 decimals. Once you have that, the world's our oyster. We can find z-scores, we can find percentiles, all that fun stuff. So for this specific sample, I know I found 810 people said that they thought Mr. P was awesome. So I stated that, and now I find its z-score. 810, my x, minus my mu of 788, divided by 6.28, and that's a z of 3.42. That sample was 3.42 standard deviations above the mean, and you can find it. Here's 810 way up there. That's why we draw the picture. Have to draw the picture. Now, statement 5. That's where it might get interesting here. We have to state if this is a rare event or if my p-value is wrong. So this 95%, it's at a recent study. I'm just polling people. That probability can change. Math probabilities don't change. They're always 50% for a coin. This one can change. If I beat someone up, people don't usually like that, so maybe my polling would fall. So in this case, I would state that this is statistically significant. I can say that right off the bat because I know that my z-score is bigger than 2. But my conclusion is my p-value is wrong for this sample. So again, we can only say for this sample maybe where I polled, but I would say it looks like it might be even a higher probability that they think I'm awesome. But, oh, I mean not me, just Mr. P. The goal is here, we want to talk about our p-value. Maybe you flipped a coin and you got a rare event. That happens. We're talking about 5% on the outside here, outside of 2 standard deviations. So are you going to get values out here? Yeah, they're rare. Maybe you want to take more information. Maybe you want to go out and do another study and see if maybe that p-value has changed. And that's what we do in statistics and that we do in life. We find interesting occurrences, we look more into them. So this is statistically significant, making conclusions from binomials. Hopefully this helped. And we'll practice a lot with this tomorrow in class. Have fun. See you later.